Now let's talk about throttling. So in Lambda, we can do the invocation with several ways. So the throttling has to be handled also differently for each type of invocation. Now as we discussed, when a certain function is not able to handle the request because it has crossed the threshold limits defined of the resources, then the throttling happens. So let's talk about the first invocation type, which is synchronous. So in this case, your API gateway generally makes a call to your Lambda function and do the REST API processing. Now in this case, when the throttling happens, the Lambda will throw a 429 error code, and it will also send the information about the what level of throttling has happened. So the throttling can happen as function level as well as account level, and based on that you need to handle it at the client level. So API gateway would be getting the 429 error, and that will be passed back to the callers. The best practices to handle the throttling for synchronous processes that you create the API keys for the API gateway and give it to your consumers and ask them to pass it as headers. So based on that, you will come to know from which consumer the high volume of requests are coming, and you can easily manage how to respond back on those scenarios. Now let's talk about the second type is asynchronous Lambda invocation. In this case, the Lambda will be able to again throw the error, but it has a inbuilt retry mechanism. So it will retry that, and even if it is not able to make successes call in multiple retry, then we need to define the dead letter queue. If you don't define the dead letter queue, then the event will be discarded and you will lose the data. So the best approach is that you should always define a dead letter queue in asynchronous call process. Whenever the call fails and retry also fails, the message will go and store into the dead letter queue. The dead letter queue can be implemented either using SQS or SNS, and then you have to plan for the retry mechanism to pick up the data again back from those dead letter queue and process it further. So the third type of invocation is the poll based invocation, and in that also we have two subcategories. One is stream based and second one is non-stream based. Now in stream based like Kinesis, where you'll be getting the continuous data from the Kinesis. So Kinesis has a inbuilt retry logic, so it will be keep retrying the failed transaction, failed invocation, and it will be keep trying it until the time data expires. So in Kinesis there is a expiry date for each data, and that is generally up to 7 days. So Kinesis has an inbuilt retry mechanism which it applies. You can customize it also based on your need. The second one, non-stream, is like a SQS based polling invocation. So in this case also, whenever the retry fails, it will put the message back into the queue, and then after the visibility timeout expires, it will retry that until it successfully processes the data or the retention period expires. So this visibility timeout is the period where other consumers might be using the SQS queue. So during that time it will not do the retry. It will do only after this timeout expires and when no other consumer is using that queue. So that is the way Lambda is some type of invocation it automatically handles the retry and make sure it works. In some scenarios like synchronous, you have to handle it by implementing the retry logic in the client which are calling it. In the Lambda function, if you are using the AWS SDK, that also has a inbuilt retry policy which can be customized. So the default retry policy is also there, which will be keep retrying to make a call when the transaction gets failed. So AWS Lambda provides various ways where you can handle throttling, where you can handle the retry mechanism effectively. So that is all about throttling, how to handle it. Let's move to the next topic, monitoring.